Let me start, let's put this back. It's always good to be after the break, and I had some conversation during lunch, and one guy told me that what disappoints him that since yesterday, he started several years ago, he drives his kids every morning back to the 19th century. And this is something that I think, I did not invent that, but I think we should look now, after what we've seen in the last 3 hours, how do we narrow the gap between what we've just seen, or how we can introduce the stuff that we've seen into the schooling system. So in this session, we'll start with, with Dr. Ran Gilad Bacharach. He's a Microsoft senior researcher, and he will give us a short introduction to adaptive learning to set the framework for this session. Ran, please.
So I'm going to talk about adaptive learning beyond the classroom. For those of you who are familiar with adaptive learning talks about creating a path through the content which is personalized. So the idea is that if we have a student and they need to navigate through the knowledge graph towards a certain goal, different students may have a different starting point in this knowledge graph or reach different position in this knowledge graph, and therefore they have to take different trajectories in order to reach the goal of the learning. But we're going to focus on a specific topic of social emotional learning. Social emotional learning is about learning what we sometimes refer to as soft skills. Things like recognizing your emotion, moderating your emotions, perseverance, interpersonal skills like recognizing others' emotions and being empathetic, and all the way to problem solving. Now, this topic is slightly different than many other topics that we teach at school for two main reasons that I'm going to talk about today. The first one that I'm going to talk about is about hot practice. So, when we practice mathematics, for example, there are no hot moments for practicing mathematics. But anyone who was ever near a child throwing a tantrum know that there is a hot moment, right? So just before the tears burst, there was a learning opportunity. And if you missed that, there is no longer a learning opportunity after the tears are out there. In a similar way, when you are trying to learn how to control your eating, once your hand reached for the cookie, cookies are very sophisticated. Once they are in your hand, they climb to your mouth in like seconds, right? And there is no way to stop it. But just before that, there was an opportunity. And the first question that we wanted to ask is whether we can actually detect these learning opportunities. These learning opportunities that do not necessarily happen in the classroom. They can happen everywhere and anytime during the day. And we did an experiment about this learning to control your cookie habits. And we found that using AI, we can actually detect these learning moments. So let me just explain the numbers here. We built a model that can predict that you are about to eat in the next 15 minutes. And it turns out that this model can predict in about 77% of the cases that you are about to eat. So we can detect the 77% of the learning opportunities. And whenever we detect that there is a learning opportunity, it's actually, in most of the cases, it is indeed a learning opportunity in the sense that you were really intended to eat. However, we can do even better if we build a model which is personalized to each student. So if we learn a model for each student, we can get the numbers high to the 80s. So we can detect the learning opportunities and with low amount of false alarms. So we can detect the learning opportunities, but what are we going to do about them? So now we know that there is a learning opportunity, but it's not necessarily happening in the classroom. There is not necessarily a teacher around you. What are you going to do in this learning opportunity? So you need to somehow be able to deliver the content through some digital media, such as a phone, that you typically, as most students, carry with them. But then you need to select what is the right message, what is the content to deliver in this moment. And here we did a study about learning how to cope with stress. So, as you know, there is stress in life. I don't know if you noticed that. I can tell you that standing here now in front of you talking is stressful. So a lot of what we're trying to teach people is how to cope with stress, not how to avoid it, but how to handle it. And some people are better than others in doing that. And if you look at the literature, there are many mechanisms that you can use for coping with stress. So things like using positive psychology. Positive psychology calls for thinking positive thoughts, all the way to somatic relaxation, which talks about doing some physical activity in order to relax the stress. Now we need to transform these messages into something that you can deliver through something like a phone. So for example, for positive psychology, you can instruct students to go to their Facebook timeline or whatever social media they're using and try to find something positive that happened to them in the last year or so. We know they're going to go to social media, so why don't they use it for positive reinforcement? We can also have a social version of it in which we ask them to go to the social media and write something nice to someone else as a means to relax themselves. But now we have this array of different messages that we can send, and how do we choose the right one to send? So here we use another machine learning technique, which is called multi-arm bandits. It's named after these slot machines, which are sometimes called multi-arm bandits. And when you're in a room with these slot machines, and you have to choose which one you're going to play, you have to balance between two things. One is exploration. If you didn't try a machine, you don't know whether it's going to give you a nice payoff or not. At the same time, you want to do exploitation, meaning you want to use the knowledge that you already gained about which machines work better than others in order to exploit this knowledge. And in the same way, you want to do when you're sending content to students. You want to try content that you didn't try before, and you want to exploit things that you already learned. And when we do that, we take into account both the student, because we know things about the individual student, his or her personality, but also the context. Context meaning, are they at home now? Are they in school now? And all sorts of things like that in order to cater the right message for the student. So we ran a trial. We had some students receiving just random messages, and other students were using the machine learning approach to select the message. And the first thing that you see, and this is kind of not surprising, that if we look at the number of messages of each type, so the colors here represent different kinds of messages. For the random selection, you get equal amount for any type of message. But for the machine learning selected messages, we get the different composition, maybe suggesting that some messages work better than others. But now, if we look at individual students, now each bar here represents individual student, you see that each student indeed receives different composition of messages. So it's truly personalized for the student. And the result is that it really works. So this is what we see here, is we ask the student every week to fill a survey that asks them about their preference for constructive coping strategies versus destructive coping strategies. And you see that indeed the students that were using the machine learning approach selected more constructive coping mechanisms with stress. So that's great. We talked about hot practice, so practicing in the moment. And we talked about how we can use machine learning to find the learning opportunities, these hot moments, and deliver the right content when these messages, when these moments happen. And now we're going to talk about environment alignment. So You know, when we teach math at school, some students have parents at home that can support the learning, and some students have parents at home that cannot support as much their learning. But typically, you don't have that many parents, they teach you wrong mathematics. But this is not necessarily the case when you talk about social emotional skills. It's really important to have this alignment between the messages you get at school and the messages you get at home or other environments that you are at. And the question is, how do you get this alignment? So to do that, we try to somehow hook the parents into the learning experience by sending home these kind of postcards that you see here. So we were working with a content provider for social emotional learning in the US, and they were working on a program for kids from kindergarten to 3rd grade, in which they were talking about regulating emotions. And we sent with the kids this postcard as a homework. This postcard invites them to play a game with a pirate Hardy. And in order to play the game, they have to scan this QR code and enter their secret code. The thing is that kids at this age don't have phones. They cannot do that by themselves, and they have to have the assistance of some older sibling or parents in order to play this game. So now the kids are chasing after their parents in order to play this game. And by that, they are hooking their parents into this experience. And in a sense, this kind of codes that we send them with the postcard are kind of a portal, sucking their parents into some experience that we can deliver jointly for the kids and the parent. And here is some nice quote that we got from one of the mothers whose son was participating in this program. And she said that a few days after she ran this, did this homework with her son was experiencing one of these moments. And if you have kids, you know what I mean by one of these moments. And she could tell him, you know, what would the pirate do to come down? So now they had a common language to talk about and a common experience that they could talk about. And actually, by using the secret code, we actually know about what class it is, so we can deliver even personalized content, even in this case. So, just to sum up, adaptive learning has a lot of potential in the classroom, but a lot of potential also out of the classroom. We talked about how we can use it to find the time for learning, kind of these learning opportunities, how we can use it to find the right content to deliver in this time, and how we can use technology also to hook larger circles around the student for the learning process. One thing that I didn't talk about today is about the ethics involved in all of that. Once we start collecting all this data and analyzing it, we must be very aware to all sorts of ethical problems ranging from privacy to biases, fairness, and so on. I don't have the time today to dive into that, but if you're interested in all of that, I'll be happy to share my knowledge in this field. Thank you very much.
Well, I think the two concepts came up and thank you, Ran. Personalization, and we all talk about personalization. I think that we all know that adaptive learning or adaptive is a private case of personalization. And the second one, which I found really encouraging, is the opportunities. We do have lots of opportunities in AI, in machine learning, as we already seen this morning, to enter the classroom, to enter school. And we'll talk about these opportunities with some already project pilots that we're doing in this panel now. And let me introduce the panelists, and please come up and take your seat. Daniel Seaton, Next Generation Education at Microsoft. Daniel just introduced me to his mother. He is coming from an educator's family, so no wonder why he's spending a lot of time, and you'll see that, on education in his work. Dr. Yaniv Bitton, head of math department at the Center for Educational Technology. Where is he? Oh, okay. Yaniv, please join us. Michal Avni, founder of Symbolab, and she will explore and elaborate on what she's doing for more than 70 million users around the globe. And Dr. Ronen Tal-Botzer, founder of Sense Education. Please take the seat. We will begin with Yaniv Bitton, who will connect the dots of adaptive learning in school and the classroom setting, following the national curriculum, taking the national curriculum of mathematics in Israel and put it into adaptive learning. He will follow by Daniel Seaton, an engineering manager at Microsoft Education team. Daniel is working with CET. CET collaborated with the giant Microsoft to develop adaptive engine, and we think that this collaboration is something that we encourage that, and we're looking forward for more development in this collaboration. To develop this adaptive engine and to help us understand how adaptive learning can simply work, integrate, and implement in the classroom setting. We're still in the classroom, and we want to, as I said, narrow the gap for that. So Yaniv will start by describing the pilot that we're doing in the field in this last 2 years, and he will immediately followed by Daniel, who will put in the maybe the technology part of that. So Yaniv, please.
אז ישבתי על ספסל עם נעמי על גינה פסטורלית ושאלתי אותה אם אפשר לרגש בשפה שנייה כמו שאפשר בשפה ראשונה. אז נעמי, ראש תחום שפות ומתח, אמרה שהיא חושבת שפחות. אז החלטתי לספר את הסיפור בעברית ממש בקצרה. אז לפני שנתיים שיצאנו לפיילוט של Adaptive Learning, ביקשנו מכיתות להתלוות אלינו לפיילוט, ולאחת המורות שהסכימה לפתוח את שערי הכיתה שלה, הייתה בקשה מאוד מוזרה. היא אמרה, אני מוכנה להיכנס לפיילוט, אבל יש לי איזה תנאי אחד קטן, אני מעוניינת להוציא את אחד התלמידים, אני אקרא לו דני, אני מעוניינת להוציא אותו מהכיתה, כי הוא גם חלש במתמטיקה, וגם הוא יכול להרוס לנו קצת את השיעורים האלו במתמטיקה, אז בואו נוציא אותה. כמובן שלא רצינו ללכלך את הניסוי, ורצינו לשמור על דגימה מהימנה, ושכנענו אותה כן להשאיר בסוף. לאחר שבועיים שחזרתי לכיתה, אני שומע שקט כזה בכיתה, ואני אומר, רגע, אבל איפה התלמיד הזה שהיה אמור לעשות לנו את הבעיות? הייתי בטוח שהיא הוציאה אותו מהכיתה, ואז אני אומר לה, לא משנה, בשם של המורה, שאלתי אותה, איפה התלמיד? היא אומרת לי, אני ואני מתביישת קצת. הוא הפתיע אותי, גיליתי פתאום תלמיד חדש. אני חושב שזה סיפור מרגש, בטח ביום השני של פתיחת הלימודים במשרד החינוך. טוב, מעבר אחד. Let me take you back a few years to when you were in the school, and I would like to ask you two questions. The first question is, can you remember a lesson in your past where you felt that the pace was too fast in the teacher, was leaving you behind? The next question is, did you ever feel the opposite experience, okay, where the lesson was so slow that you lost interest? If so, please raise your left hand. Oh, it's okay. So, I guess you can put your hands down now, okay, it's okay. And I guess that over 80% of you had both hands up. So, does this surprise you? You can say yes, no, no, okay. So, if yes, you shouldn't. These two questions represent two extremes exist in many classes. On one end, there are students with strong abilities who are so deep in their comfort zone that they are not challenged enough in the classroom. On the other On the other hand, okay, let's try to see, there are weaker students who are in the panic zone. Their abilities are lower and the challenge in the classroom are too hard for them. They feel pressure, anxiety, and frustration. So what is the fact? The sad fact is that we are failing both types of students. So how can we challenge all the students to really learn? So personalization, before speak about, personalization of learning process can motivate those who find the work easy and those who are struggling, so that all types of students can experience motivated learning and progress at their own pace. Ideally, a teacher who can match the instruction to teach students individually can make sure everyone learns. So, however, in regular classes, a lot more help is required to reach each child. So perhaps traditional methods just aren't enough. So do we have a solution here? We actually do, and this is adaptive learning. So to explain the impact of adaptive learning, I would like to repeat about the story, but now in English. I would like to share a success story with you in 1 hour of pilot. The teacher made a special request and said, I would like to remove Danny from the class when we have the adaptive lessons, because he's very weak in maths and will probably disrupt the lessons. So we answered that we want to keep our experience clear of bias, and we convinced the teacher to keep Danny in the class. 2 weeks later, we returned to the class and asked the teacher about Danny. She was embarrassed and admitted that she had seemed to turn into a different child, responsive, well-behaved, and making good progress. So, how did our technological solution help Danny keep up with his class? In our maths unit, we chose to begin with 4th grade fractions, okay, 4th grade fraction. The main reason for this choice was that the subject requires almost no prior knowledge. This is one screen out of the 6-screen activity, which focuses on different names for the same fraction. The student can learn independently using video clips, solving problems, and doing interactive computerized maths labs. In the first pre-adaptive stage, the students are asked to solve all the problems without the ability to skip any exercise. In parallel, we track the number of tries it takes until students answer correctly, if and when they use help or scaffolding, when they ask help from the teacher, and when they indicate in the system that they don't understand. And also, how long it takes students to solve each exercise. Tracking helps the development team to learn from different points of view, for examples, question formulation, content, and level of difficulty. This is important for creating user profile and content profile that enable us to put students on different tracks tailored to their needs. Over the last year, we ran pilot with adaptive learning engines that allowed students to skip about some stages. Daniel will expand about the adaptive engine later. It is important to point out, we often think that when students skip stages, it's because they are stronger. But it is not always true. Sometimes the system skips challenging or more difficult materials only to return to it later stage, when the student is better equipped to deal with those exercises. I would like to go back to Danny, our weak student in maths. Danny was actually able to surprise his teacher in the pre-adaptive stage. This is a great start. Imagine how the adaptive engine can help Danny. The last question that I would like to ask is, what happened to the role of the teacher? Maybe it's new role now. I'm sure you will agree that this is an extremely important question. We often think that the adaptive learning can replace the teacher in the classroom. This, however, is a mistake, a big mistake maybe. The last year have proven us the importance of the teacher roles in the adaptive classroom. The adaptive learning environment provides teachers with details report which help them understand the diversity in the classroom at any given moment. Teacher can then help students individually or in a group basis according to their needs, while the rest in the classes continue independently. This system brings us scholars to real tailor-made learning. Okay. The last important role of the teacher is the empower of the student. I would like to return to Danny, our weak student in mathematics. If the adaptive learning system is able to help teachers to empower students like Danny, then it is a great success story for them, and I think that for all of society. And Danny, thank you.
So thank you very much for having us in. I'm Daniel from Microsoft, and in the next couple of minutes, I'm going to focus on the engine that Microsoft built for the CET experiment that Yaniv described. But just before I talk about this specific project, I want to say a few words about Microsoft's work in the education space. Is this working? Let's use that. Okay. So our mission in Microsoft is to empower every person on the planet to achieve more. So naturally, education is important to us. The education team is responsible for bringing the best tools to the classroom. And so we take Word and Excel and Teams and OneNote and adjust them to the needs of students and teachers. And in the roadmap for that is also personalization. Yaniv talked about the need for personalization or differentiation in the learning path, and I would like to continue from that point. So let's look at two students, A and B, and these two students are, this is real data, and this is from the pre-adaptive phase. And the students are going through the content that Yaniv described, the digital content, and the system captures their behavior and the performance in the system. And let's look at the data. First user, student A, is doing okay. First item, he completed in 28 seconds successfully. The second one in 22 seconds, and so on. No sweat. Student B, however, is clearly struggling. We can see that he managed to solve the first item after more than 2 minutes, but my guess is that he got some help there, maybe from a teacher or a peer. He tried to work on the second item for more than 2 minutes, but eventually gave up, and he failed to complete any of the other items. Just think about it. It's the same content, but such a different experience for each of those students. Okay? Now, Yaniv also mentioned those zones, the panic zone, the challenging zone, the comfort zone. In the eye of the adaptive engine, it's actually a continuum. And building on the concept of the zone of proximal development by Vygotsky, we claim that effective learning occurs when the content is getting more and more difficult as the student is gaining mastery. So only when those two things are well aligned, we have effective learning happening. And the goal is to reach that perfect balance. So going back to our two students, so even though it's the same content, so it's the same horizontal line, it's the same content difficulty, those students are in opposite directions of the zone of proximal development, of the effective learning. An important fact I want to stress out, which enables us through the digital content, we can, with high probability, infer from the data whether a student is in the zone or outside the zone. If we see many failures, if we see lots of duration, long durations more than average, if we see the student using lots of hints or just abandoning a task like we saw before, these are all strong indications that the student right now is in a panic mode, is over-challenged. And in a similar way, if we see sequences of fast success, low use of hints, students skipping content by himself if he's able to do so, these are, again, indications he's under-challenged. And now comes the machine learning magic, which enables us to look into the future. But for that, we need data, right? So we need historical data. We need lots of students working on that content. We need the student performance as they work in the system. And we also use features from the content. Is that a lab? Is that a simulation? Is this more of a practice versus creative thinking, problem solving? All those things give us strong indications. So given those data, we can create the machine learning models. And the machine learning models enable us to look into the future, meaning for a student and a task that he has not seen yet, we can make highly accurate predictions. What is the likelihood for this student on that specific task to complete it on the first attempt? What is the likelihood for him to complete it faster than average, to use hints, or to abandon it, and so forth? And then we can take all those predictions, and maybe these are just 5 or 6 out of the 80 that Yossi Vardi mentioned in the beginning, but it's enough at least to make that prediction whether this question for that student in this amount of time, it would be in the zone or outside the zone for this user. Going back to our 2 students, what would happen if we turn all the algorithm for them right now? For student B, the engine, the algorithm, would select easier questions he's more likely to succeed in. That would rebuild his confidence, that will reinforce his knowledge, getting back to effective learning. In a similar way, student A, the system would select for him harder question he's less likely to succeed in, that he would probably going to use hints for, challenge him, bringing back into effective learning zone. Okay, so we built the system, and CET ran the experiment, and we monitored it from our side. And the experiment itself, it's a full session with many, many details. I want to share, or at least talk about 3 things. So first is privacy. In Microsoft, we're dead serious about privacy and protecting student data. We're making sure we're not getting or storing any information that can identify the student, not even gender or demographics. So this is very important for us. Second, we heard a lot about big data and deep learning and all those things. Look at the numbers. This is considered a very large experiment in the education field. And it's a huge operation. I mean, big kudos to my friends in CET for running this. It means training the teachers and being in the classroom, assisting the teachers. It's hard work, and it's considered a very large experiment. And lastly, it's an A/B experiment, and I'll just say a few words about it. It means roughly that we take half of the class randomly and give it an adaptive experience. On the second half, you use the pre-content with a fixed path. So you need to go through a set of questions that are known, and they can skip a little bit within their learning units. And we measure the effect, and we measure the progress of these 2 groups, and we compare them. And at some point in time, we switch the groups so all students can enjoy the adaptive, and we have a fairness. I would like to show you some of the results. The first thing we notice is that the adaptive students spent more time on their tasks. What do you think? Is that a good thing or a bad thing? It's good. They worked on less questions, but each such question, they invested more time in it. The reason is that the linear path was kind of tuned for the below average student. So there were a lot of students we can push forward to more effective learning. Second, we saw that success at first attempt for the adaptive students was lower. What do you think? Is that good or bad? It's a very good thing. We gave them questions. They didn't know the answer up front. That means they had to open the videos and watch the aids and think, learn. And maybe the third thing and the most interesting and surprising finding we had is that we saw a significant and a very dramatic effect that adaptive students, 24% higher, likely to participate in the exam, in the final exam. And actually, we're not sure what drove that figure. It might be that we move them faster through the curriculum, and therefore they had more time to take the test. It might be that maybe they were more confident about their knowledge. We're still investigating the root for that, but it's a very positive effect that we saw with adaptive. So just to wrap up this part, we saw them working harder, we saw them more engaged, and we saw them participating with higher numbers in the exam. So this is all goodness from a pedagogical point of view. By the way, to me, this is not surprising. It feels more like a video game. You do something, and the content respond to that. You succeed, and you get a reward. It's not like the student is fighting a fixed textbook. The student and the content are working together to complete a task. And I think that some of that thing went through the experience into the eyes of the students. I would wrap here. I would just say that this is not a product Microsoft is going to sell. This is something that we're building in my team as a collaboration with CET. It's a true passion for me. And it's also an opportunity to build something that my kid used in the classroom and my younger kids will use soon. And I believe we got some glimpse of the potential in the future ahead. Thank you very much.
Well, this partnership between Microsoft and CET and also the enthusiasm of both entities to go forward with this. So I encourage Microsoft to continue to invest in education with us. And we call upon all giants, technological giants, to really partner with educational organizations and companies to advance adaptive learning into the system. The system needs it. But we don't have a lot of time, but we have two great entrepreneurs here who are really practicing machine learning and AI in learning. And I just want to ask you some questions. We'll start with Michal Avni. Please tell us a bit about Symbolab, and more precisely, how is it facilitating the student to learn, or one may say student learning?
Hi. Symbolab, we make math simpler. We actually help students learn math. We're doing a lot of things, but I'll focus on the two main components. First and foremost, we solve any math problem with the steps. So you all know that there are more than 60% students suffer from math anxiety. We will not get into the other 40%, how many really know or love math. So the main problem is they see in class some examples or in videos on YouTube, but when they are faced with other problems, they just don't even know where to start, because in math, every problem is different. So the solutions serve as anchor. The student can type in any problem and see the process, and they're not lost anymore. Our users call it a lifesaver. I'll just mention that we have more than 70 million users, so that's a lot of users to learn from and to really base our AI on. The other component is also adaptive learning. We give the students, we adapt the learning process, so each user gets the problems that are just right for them. We also did some tests, and we saw something very interesting, that we saw the engagement 10 times more than non-adaptive problems. So adaptive learning definitely works, and we're not working with classrooms or teachers, we're just working with the students. We really believe that the students should be in the center, and the students know what they need. So both is using AI, sophisticated algorithms, machine learning, deep learning, and all that stuff.
Okay, thank you. Maybe we'll come back, but now let's move to Ronen. So Michal is focusing in her Symbolab on the students' learning. And we know that the famous McKinsey report 2007, which put Finland at the top of educational system, but the slogan or the motto was that a quality of education system cannot exceed the quality of its teachers. And I believe that all of us or most of us believe in that motto. And Ronen, you are focusing on helping the teacher in your adaptive engine, or please tell us a bit about that.
Thank you. We are Sense Education, and I'll try to connect what we've seen here to what we do, but we have a different approach, for better or worse, to adaptive learning. And it is based on two things. One is the understanding that there is no adaptive learning and no personalization without true, thorough evaluation of the students. And this is something I think everybody can relate to. But the second is that we don't look, and this is what makes us different, we don't look at periphery data, we look at the core data. You know that in any machine learning, big data application, you need to look at the data. Periphery data is what we see, like, you know, looking how much time it takes for a student to solve a problem. Core data is what is the answer, what is the solution. And this is what Sense is looking at. Sense is looking at students' answers, what they say, at the content of the answer, at how they build a solution. This is the core data, and this is our use of artificial intelligence. In many cases, we see that because of people change pedagogy because of technological limitations. So they measure what is easy to measure. The data is the periphery data. We, like multiple choice questions and time spent on assignments and so on, we look at the answers. If a student wrote that a photosynthesis produces oxygen or produces energy, that's two different answers, we enter that level of what is the correct answer. So we use AI in order to get all student solutions to a problem. The AI really doesn't understand what is the good or bad solution. But what it does is based on a pattern that says, even if you have 100 students or 1,000 students, and you ask them a question, you don't really get back 100 different solutions. So we see that we show the educator, the professor, the teaching assistant, that maybe began with 100 students, but here he has a group of 20 students that solved basically in the same way. And here he has a group of maybe 30 students that solved in a very similar way, but different from that way. And so that way we show the professor the different groups of solutions or the different archetypes of solution, and then the human intelligence, the professor's intelligence comes, evaluates each group, maybe there are 7 or 10, not so much, not so many, and provides the grade and the educational feedback. So this is the evaluation of the student done that way, looking at the core data, and in a scalable manner is at the basis of adaptive learning. Based on this grouping technology, can you then provide the adaptive next assignments and, of course, other more personalized content. So this is what Sense is doing.
Thank you very much. And I think that maybe the conclusion of what we've heard and seen in this session is that when somebody comes to you with a new technology or a new solution for learning, ask him 3 questions. Is it personalized? Are you using data? And is it adaptive? If the answer is no to one of them, show him or her the door. Thank you very much. And